FATEC Motion Module 5, Point Table 2. This chapter focuses on the point table in the motion control project. Introduces Step 4 and its extensions in the process of writing a motion control project. This chapter introduces the interpolation in the point table, which are divided into linear interpolation and circular interpolation. Interpolation uses interpolation methods to calculate the data of the motion path, enabling the realization of any curve planned by the user. The master axis and the interpolation axis work together to draw a path. In the point data setting, select Linear in the operation mode. In the linear interpolation, the velocity should be calculated based on the path length of the two axes by finding the hypotenuse using the Pythagorean theorem. When you select the arc interpolation mode, the arc setting parameters appear automatically. Arc mode has three types: border point, center, and radius. Differences are shown in the table. When using the border point mode, ensure that the starting point, border point, and target are not collinear, and any two of them should not be the same point. In center mode, need to set the coordinates of the center and the arc direction. If the set center is not suitable, the system will find an appropriate new center along the line formed by the starting point and the user set center. In radius mode, the system will automatically choose the small arc. If the starting point and the target are the same point, a complete circle will be drawn. Next, demonstrate linear interpolation and circular interpolation. Point 2 Virtual axes. Same axis settings. Set the point 6 as the two-axis relative coordinates linear interpolation in the point table. The target position is 100 degrees and 100 degrees. The speed is 100 degrees per second. The acceleration time and deceleration time are 100 milliseconds. The set point 7 is the two-axis arc interpolation of the relative coordinates. The target position is minus 100 degrees and minus 100 degrees. The speed is 100 degrees per second. The acceleration time and deceleration time are 100 milliseconds. Select the center mode, and the coordinates of the center of the circle are minus 100 degrees and 0 degrees. The direction is counterclockwise. Next, set up the motion flow. Right-click to add Motion Flow 3. Add a new selection branch from the toolbox. The selection branch is similar to the parallel branch, and the left condition is set to R100 equals 0. Add a new positioning control flow block for point 6 to the left. Add a new positioning control flow block for point 7 to the right. Right-click on Select Branch and select Auto Merge Branch. Add a standby flow block with 1000 milliseconds. Add Go-To flow block to jump back to Select Branch. Add End Process block. Add an A contact M3 to connect to function 176. Enter 3 for Flow 3. Click Online Monitor and download the project. Once the download is complete, run the PLC. Open the monitoring chart and monitor the command coordinates of axis 1 and axis 2. Open the 2D chart and set the X-coordinate data and Y-coordinate data sources. Run the monitoring chart. Enable M3, switch to tab of Motion Flow 3, and observe the motion trajectory from the 2D diagram. Change the value of R100 to switch between the left and right branches. Demonstration complete. Speed continuous, auxiliary arc and 3D blending. Next point speed. When the first point positioning control is complete, the current velocity is the velocity of the next point. Current point speed. When the first point positioning control is complete, the starting speed of the next point is the maximum speed of the first point. Start speed. Moving to the next point after reducing to the initial speed. Next, demonstrate the velocity continuity function. To the point table. The set point 8 is the relative coordinate of the single axis. Input main axis 1, the target position is set at 100 degrees. The speed is set at 100 degrees per second. The acceleration time and deceleration time are set to 100 milliseconds. Set the continuous point to point 9, or press the next button. Select the next point speed continuously. Press OK. Point 9 is automatically generated. Point 9 and point 8 are set the same. The speed is set at 50 degrees per second. The continuous point is set to point 10. Elect the current speed continuously. Press OK. Point 10 and point 8 are set the same. No continuous points. Added Motion Flow 4. Added the positioning process block. Select point 8. You can see the subsequent continuous points in the window. Press OK. Add End Process Block. Add an A contact M4 to connect to function 176. Enter 4 for Flow 4. Click Online Monitor and download the project. Click Online Monitor and download the project. Open the monitoring chart and monitor the command speed of axis 1, and monitor the current point number for axis 1. Run the monitoring chart. Enable M4. Stop the monitoring chart. On the left, magnify the gain of the current point number by 1000. In Chart 1, right-click to activate the cursor function. Adjust the velocity of axis 1 when the number of current points changes in Chart 1. Demonstration complete. The auxiliary radius makes the corner parts of the trajectory between points smoothly connected. As continuous arc motion can be performed without stopping at corners, it reduces mechanical vibration and shortens the moving time. The blending percentage is the ratio of the length over which two movements blend together. When blending value is 10%, positioning of point 2 will start at 90% position of length of point 1. Monitor chart, 2D and 3D chart. Click this to open or close the 2D plane of the monitor chart. Click this to open or close the 3D plane of the monitor chart. Next, demonstrate a 2D continuous auxiliary arc. Copy points 6 to point 11. Copy points 7 to point 12. Set point 11 continuous points to point 12. Set the current point velocity continuous, and the radius of the auxiliary arc is 5. Set point 6 continuous points to point 7. At this point, there is no auxiliary arc before points 6 and 7, and there is an auxiliary arc between points 11 and 12. Set point 7 continuous points to point 11. To continuous 2 path. Click Online Monitor and download the project. Once the download is complete, run the PLC. Set R100 to 0. Open the monitoring chart and monitor the command coordinates of axis 1 and axis 2. Open the 2D chart and set the X-coordinate data and Y-coordinate data sources. Run the monitoring chart. Enable M3. Compare the difference before and after setting the auxiliary arc. Demonstration complete. Practical application of the contents of this chapter. Milling machine. Here is the video of a SIM card milling machine, and its controller is M-Series PLC. The SIM card milling machine is completed using simple linear and arc interpolation. Painting machine. The M-Series PLC is also using in painting machine. In the M-Series PLC, not only is the linear path easy to set, but the circular path is also straightforward. The painting machine uses arc interpolation for back and forth motion. After this chapter, you can find some applications for M-Series PLC.